Okay, so in this video we're going to have a look at binomial expansion. By the end of the video we're going to be aiming towards answering a question like the one on the screen here, where we're looking at working out the first three terms in ascending powers of x for a binomial expansion of something like this shown just here, 1 plus px to the power of 10. And obviously looking towards solving a problem to do with that as well. So looking at sort of the coefficients of x squared and trying to solve one of these problems. So this is what we're going to build towards, but we're going to start right at the beginning and having a look at binomial expansion right from sort of something that we did at GCSE level and building it right up to one of these more tricky problems. So we're going to get started on one of those now, and here it is. Okay, so when we're looking at binomial expansion, essentially, if we're thinking about from GCSE level where we've looked at expanding and simplifying a triple bracket, we're going to look at sort of how this all sort of interlinks with then higher powers when we have sort of a bracket to the power of 5 or to the power of 8, and how we go about finding those powers using this process. Now when it comes to binomial expansion, it's all sort of interlinked with sort of the separate powers when we've looked at brackets. Now if we think about sort of a nice easy one, something like x plus 5 in brackets squared, we get a certain pattern that sort of comes out of these, and when we expand one of these we get the x squared, we get that first piece there is always to that power of 2, then we get the 2 in the middle, we get plus 5x, and we always get these 2 there, and then you get that 5 at the end which is squared as well to make 25. And then obviously those 2 in the middle are added together, but we get this sort of little pattern, and it's all linked to Pascal's triangle. And Pascal's triangle is nice and easy to draw. We get a 1 at the top, then you add together the numbers either side of it to get the ones below, and obviously 1 at the top's got a 0 either side, so we just have 1 and 1 below that. But then when we add these together we get 1 on the left, those 2 ones add to make 2 in the middle, and then we get 1 on the end, and we can just keep following this process and making this pattern, so always 1 on the outside, then the 1 and 2 above this next one makes 3, 2 and 1 makes 3, and 1, and we can keep on going, 1, 3 and 1 makes 4, 3 and 3 makes 6, 3 and 1 makes 4 again, and then 1 at the end, and we can keep on going basically with this. Now when it comes to this double bracket that I've drawn here, that is this row here, so 1, 2, 1. So we get 1 of the pieces at the start, the x squared, we get the 2 pieces in the middle, okay, which we've obviously just shown there, we get the 2 in the middle, and then we get the 1 at the end, and following that little pattern of 1, 2, 1. Now if I come away from that and we have a look at this triple bracket, which is what we're going to have a look at to start with, that is obviously linked to the next row down. Now that next row down is 1, 3, 3, 1. Now it's not as easy to spot the pattern with this one, but obviously if we were to expand this all and have a look at all the pieces, we would see we get the 1 at the start, we always get an x cubed at the start, we get the 1 number at the end, which is going to be that 3 cubed, which we'll have a look in a sec, and we get these 2 lots of the 3 pieces in the middle, and we're going to have a look at those now. So if we have a little think, when we were to expand this at GCSE, obviously what we would do is we'd expand 2 brackets to start with. So we'd do x plus 3, and we're going to fully expand this. I'm going to do it nice and quick though, and x plus 3. We'd expand that, which gives us x squared plus 6x plus 9. And then we expand that by another x plus 3. There we go. And we do that, and we expand this all out. We get the x squared times x gives us x cubed. The x squared times the 3 gives us 3x squared, and then we go on to the 6x, and we just keep following this process. So 6x times x is 6x squared, the 6x times the 3 is 18x, 9 times x is 9x, and 9 times 3 is 27. Okay, and we simplify this all down, so eventually we get x cubed plus, and we've got those 2 lots of the x squareds there, which gives us 9x squared. The 18x and 9x gives us 27x. There we go, plus the 27. And we end up with these 4 pieces here. And as you can see in that line, we've got those 4 pieces. Now it's not quite as clear with the triple bracket here, or with the bracket to the power of 3, as to how we got those 2 lots of 3 in the middle. But essentially we kind of got, and let's have a look, we've got the x squared here, 1, 2, 3 pieces of x squared. And we also got 3 pieces of x. We've got the 18x, the 9x, the 6x. And then obviously we've got the numbers on either end as well. We've got the x cubed and the 27. So you can kind of see where this pattern comes from. You've got the 1 lot of the x cubed, the 1 lot of the number at the end, and then the 3 of each piece coming in the middle there. Obviously eventually we got to x cubed plus 9x squared plus 27x plus 27, but we're going to have a look at how we can actually get to that using binomial expansion and using this process within Pascal's triangle. Now obviously We don't want to have to always draw this triangle out every time, and thankfully there's a nice little button that we can use to get that on the calculator. And if you have your calculator, this is a calculator topic, it's a button that looks like this, and it tends to be that you've got to press shift to get there first, but it says NCR. And it's normally behind the divide button, so you still normally have to press shift divide, and it gives you this NCR. Now in order to get these numbers here, which was what we're going to use for the first one, we have to press, obviously it's a power of 3, so we press 3, shift, that NCR button, and you'll get a C, and then we press 0 for the first one, so 3C 0, and that always gives us a value of 1. We always get that 1 for the first one, which is just there. Now for the next one, we press 3 again, 3, C1, and we get 3C1, and that gives us 3. Then we do it again, so swap the 1, but I go for 2 this time, so 3C2, and that gives us, let's just have a look, we get 3 again, and then for the last one we're going to do 3C3, which gives us 1. So make sure you know what that button is in your calculator. It's normally just behind the divide, so 3, shift NCR, and then whatever number we're looking for. We start with 0 and then 1, 2, 3 for those next ones. So we can actually find out what the pattern's going to be just using this button on our calculator. I'm going to be using that throughout the video, so this is going to be a very important little button. I'm going to be using that every question and mentioning that as we go, but as I said, you've got to press shift first to get there. So let's have a look at how we can actually use that on this question, making sure that we can obviously expand this triple bracket using binomial expansion before we start looking at higher powers. So if we get rid of this, obviously we can get rid of all of this. We know what answer we're trying to get to, and that's this one here, x cubed plus 9x squared plus 27x plus 27. Okay, so we obviously know that from GCSE level that that's going to be the answer. And let's look at using binomial expansion to get there. So once we've got the pattern then, and we've got NC0 is 1, and we've got 1, 3, 3, and 1, and that's going to be our pattern. Now all we do is we look at the two pieces within our bracket. So we have an x as the first one, and a 3 as the second one. Okay, and let's just highlight that in different colours. We've got an x, and we have a 3. So that first piece, that 1 there, the x, is obviously the first piece in our pattern, and we have one of those. So we have one lot of, and that's going to be x, and everything here is going to have to be up to a power of 3, so that's going to be x to the power of 3, and we have one of those. So all of these little pieces we're going to write now, we need to make sure there's always a power of 3 in all of them. Now the next one, we're going to have 3 lots of this next piece, so we're going to add to that 3 lots of, and the next piece is ever so slightly different. Now x, the first one, we're going to drop down that power now because we only have one of those x cubes in there. So that x piece is now going to go down to a power of 2. So 1x to the power of 2. But we need to make sure we balance out these powers, and the next piece that we're going to throw in there is that 3. So we have then a 3, and that's going to be to the power of 1. Not that we need to write the power of 1 there. Okay, so all we're going to do is reduce that first piece, which in this case is x, so that's gone down to a power of 2, and introduce that next piece in the bracket, which is a 3. And we're just going to swap these round now, so the x is going to keep reducing, and that number, the 3, is going to keep going up in powers until we get to a power of 3 for that one as well. So the next one, and again we've got 3 lots of this next piece, so we're going to add to that 3 lots of, and we have x to the power of 1 this time, that's going down to the power of 1, and that 3 is going to go up to a power of 2. There we go, that's our third piece in that pattern done. And then on to the last piece, we have one of these, so we're going to add to this 1 of, now x is going to go down to the power of 0, so that's gone, and we just have this 3 at the end, which again has to balance out to that power of 3, so 1 lot of 3 cubed. And if we expand these all out and see what we get, 1 lot of x cubed is x cubed. There we go. Then we're going to have 3 lots of x squared times 3. Well, let's just do the 3 times the 3 to start with, which is 9. So that's 9 lots of, and then we've got x squared with that, so 9 lots of x squared. Then for the next piece, let's have a look. We've got 3 lots of 3 squared. 3 squared is 9. 3 times 3 squared, so 3 times 9 is 27. Again with that x to the power of 1, so plus 27x. And then at the end there we have 1 lot of 3 cubed. 3 cubed is 27, so plus 27 at the end. And there we go, that matches obviously what we got from expanding our triple bracket at the top. We've got x cubed plus 9x squared plus 27x plus 27. So that's all we're going to do for binomial expansion. Obviously it gets a little bit more complicated as we start to go further down Pascal's triangle and start to get larger numbers involved, but basically that's all we're going to do. We're just going to write down what the numbers are obviously in that line of Pascal's triangle that we're going to be looking at, and obviously just balancing that out with our powers sort of moving through. But let's have a look at another one and see how we can apply this to a slightly harder question. Okay, so we have expand 2 plus 5x to the power of 4, simplifying the coefficient of each term. So let's have a look at this one then. Now, in this particular question, we've got a power of 4. So for a power of 4, we're going to first find out what the pattern is of Pascal's triangle at that point. I'm going to use the calculator to do this. So we're going to do 4C0. So I'm going to do that on my calculator now. 4, Shift NCR button 0, and we get 1. So we've got 1 for the first one. Swap the 0 for a 1, so 4C1 is 4. Back in, swap it for a 2. So 4C2 is 6. Back in, 4C3, which is 4. And then 4C4, which is 1. That gives us that line of the triangle there. Now having a look, again we know it's a power of 4, so everything's going to have powers of 4 in this one. We've got our first piece, which is a 2, and our second piece within the bracket, which is a positive 5x. So if we start writing this down, well, we've got 1 to start with. Let's start with the 1. So we've got 1 lot of the 2, the first piece, and that's to the power of 4. So 1 lot of the 2 to the power of 4. Just like with all normal double and triple brackets, we always get that first piece there at the start to the power of 4. On to the next piece, we get 4 lots of this next one. So we've got 4 lots now. So we're going to add to that 4 lots of, and we've got 2, which is now reduced to a power of 3, and now introducing that next piece, which is the 5x. So 1 lot of the 5x. I won't write the power of 1 this time, but we've got 1 lot of that. Then we've got on our next line, we've got 6 lots of this next one. So we have 6 lots of, and we've got 2 being reduced to a squared, and 5x increasing to a power of 2. There we go. And on to our next one. Let's have a look. We've got 4 lots of this one as well. I'm going to run out of space here. Let's move this to the left a bit. There we go. So we're going to have 4 lots of this next one. So we have 4 lots of 2, which is now down to a power of 1. It's decreased. And the 5x, which goes up to a power of 3. And there we go. And now on to our last one. And we have 1 of these. So we have 1 lot of, and it's 5x, this time to the power of 4. There we go. And notice on every single piece there we've got a power of 4. Even though I've not written in these ones, I could write them in. If you have a look, both pieces there, in total we've got a power of 4 on every single piece. Now if we go about expanding all this and simplifying it down, let's see what we get. And again we're using a calculator here, so we've got 2 to the power of 4 as our first one, which is 16. So we have 16. Then we have 4 lots of 2 cubed. Let's have a think. So 2 cubed is 8. Times that by 4 is 32. So we've got 32 lots of 5x, which we'll sort out in a sec. Then we have 6 lots of 2 squared. 2 squared is 4. So 6 times 4, which is 24. So we have 24 lots of. And 5x in brackets squared is 25x squared. There we go. It's just squaring both of those. Again, you can use your calculator for that. For the next bit, we've got 4 lots of 2, so that's 8 lots of, and then we've got 5x cubed in the bracket, which is 125x cubed. And then for the last piece at the end, we've got 5x to the power of 4. 5 to the power of 4 is 625. So we have plus 625x to the power of 4. There we go. Last little bit of sorting out to do because we've got a couple there that we can simplify a bit more. We've got 16 at the start, which is fully simplified. 32 times 5x, well 32 times 5 is 160. So we get 160x. 24 times 25 for the next one, which is 600. So we get 600x squared. 8 times 125 for the next one, which is 1000. So we get plus 1000 x cubed, and then plus the 625 x to the power of 4 at the end there. There we go, and that finishes that off. So obviously, as you can see, it gets a lot more complicated when we've got these higher powers, and it's harder to see the pattern than it is to see it with a double bracket where we have a bracket squared, because obviously the actual process for expanding all this would be very complicated. Obviously we'd expand two brackets, times it by another, and we'd get so many of these pieces that it would just take absolutely ages for us to expand. So here's a nice quick way of us expanding these and following those patterns. Okay, but it's all about, obviously, when we've got these two pieces, the first piece, which I've got highlighted in yellow up here, starts off with that power of 4 and just decreases in power till it disappears, and that piece on the right there obviously is introduced in the second piece and starts increasing in powers right up to the end where it finishes on that final power of 4. We're going to have a look at another one of these before you have a go, so let's have a look at that one. Okay, so there's some slightly different language in this one. It just says find the first three terms. And that's because it's starting to get up to the power of 5. And as you get to the power of 5 or 6, 7, 8, 9, 10 and beyond, there's so many pieces to write down. It just takes absolutely ages to write them. So we tend to just be asked for the first 3 or the first 4 terms. And it says in its ascending powers of x here. Obviously just writing it as we have done to start with. So this is of the binomial expansion of 2 minus 3x to the power of 5. And again, given each term in its simplest form. So if we have a look, obviously in this one here, our first piece is a 2, and our second piece this time is a negative 3x. We're just going to have to watch out for that negative on this one, but that shouldn't be any problem really, as we're using a calculator as well. But obviously we just need to find what the first 3 parts of that pattern are. So for the first 3 terms when we have a power of 5. So easy enough to do on our calculator. We do 5c0, which is obviously 1 always for the first one. Then we're going to do 5c1, work that out, and 5c2. That's going to give us our first 3 patterns of Pascal's triangle on that row. So let's have a look. 5, and we have C1, which is 5. There we go. Swap that for a 2, so 5C2, which is 10. There we go. So there's our first 3 pieces, or the amount of each piece that we're going to have in this expansion. Right, so let's have a look. So the first one we have one lot of. So we have one lot of, and that piece there is a 2, the first piece. So we have one lot of 2, and again, making sure we have that power of 5 in there. And then for the next one, let's have a look. We're going to have 5 lots of. So we have 5 lots of, and we've got the 2, which is reducing now to a power of 4, and introducing that negative 3x. I'm going to keep everything in a bracket just to make sure I don't mess up with these symbols in front of it at any point. So negative 3x, there we go. And for the next piece, we're going to add to that. And again, having a look here, we've got 10 lots of this one. So we have 10 lots of, and it's 2 being reduced to a power of 3, and that negative 3x is going up to a power of 2. There we go. And there's our first 3. And obviously this continues, but we are only finding the first 3 here. So let's simplify this down, see what we've got. So one lot of 2 to the power of 5, or 2 to the power of 5 on the calculator is 32. There we go. And we're going to add to that 5 lots of 2 to the power of 4. Let's work that out to start with. 5 lots of 2 to the power of 4 is 80. So we're going to add to that 80 lots of negative 3x, which is going to be a negative piece, and we'll deal with that in a sec. And then we're going to add to that 10 lots of 2 cubed, which is 80 lots of, and then we have negative 3x squared, or negative 3 squared is positive 9x squared. There we go, so we have positive 9x squared. And obviously just then simplifying this down, so we've got 32 to start with, and we're going to add to that 80 lots of negative 3x, well 3 times 80 is 240, and it's negative, so we're going to be taking away 240x, and then we're going to add to that 9 times 80, which is 720, so 720x squared, and there we go, there's our final answer, the first 3 terms of that expansion there. Obviously we could continue, we could keep doing Pascal's triangle there, 5 lots of the next one, then 1 lot of the final one, and keep on going, but when it only asks for the first 3, it's easy enough there, we only have to do those first few. So obviously this is really important here, knowing to use this button. Obviously 5C0, so power of 5, finding that first one, which is 0, and then keeping on going with that, just depending on what the power is there. Obviously if you said power of 7, we would do 7C0, 7C1, 7C2, and just incorporate those numbers in front of the coefficients there, just to make sure that we simplify it all down correctly. But there we go, that is how to go about doing these first lots of binomial expansion. So here's a couple of questions for you to have a go at. Okay, so here's 4 questions, so pause the video there, have a go at these, and we'll go over the answers in a sec. Okay, so for the first one, now obviously this is only a triple bracket here, so this is obviously one that you could do without using binomial expansion, but quite a nice one to be able to actually check your answer using that old process from GCSE, and obviously then continuing with that using this process. So let's have a think about this. So for the first three terms then, we've got 3C0, 3C1 and 3C2. We need to write down what they are. Obviously that first one is always 1, so that's okay. Then we've got 3C1, which is 3, and 3C2, which is also 3. So in terms of expanding this then, we have one lot of that first piece there, which is the 2x, and I'll always just highlight these. We've got the first one, which is 2x, and the second one, which is 1 there. So we have one lot of the 2x, which is going to be cubed, and we're going to add to that 3 lots of the 2x, which reduces to a power of 2, and then the 1, which is just a power of 1. And then the last one, we got 3 lots of, and we've got the 2x again, which is now a power of 1, and the 1, which is going to be squared. There we go. And if we simplify all this down, let's see what we get. So we get one lot of 2x cubed. So 2x cubed is 8x cubed. 3 lots of 1 on the next one is 3. And that's going to be 3 lots of 2x squared, which is 4x squared. There we go. And then we get 3 lots of, it's 3 times 1 there, 3 lots of the 2x. We could probably just work that out straight away. 3 lots of 2x, which is 6x. There we go. And then we just need to simplify obviously that piece in the middle there. So we've got the 8x cubed. 3 lots of 4x squared is 12x squared. And then we've got the 6x at the end. There we go. And there's our first 3 terms for the first one. Now obviously let's just have a look at the one to the right of that. So we've got a power of 4 in that one. So we need to work out 4C0 to start with. So let's have a look. We've got 4C0, which is 1. Then we have 4C1, which is 4. And then 4C2, which is 6. There we go. So there's our first 3 pieces of the pattern there. So we have one lot of the 3, which is to the power of 4. Then we have, adding to that, 4 lots of the 3 cubed this time, and then the 2x. And then for our final piece, we have 6 lots of, and we have 3 to the power of 2, and then the 2x, which is now going to be squared. There we go. So simplifying this down, let's see what we get. So 3 to the power of 4, I'm just going to do that on the calculator, is 81. So we get 81 plus 4 lots of 3 squared, so 4 lots of 3 cubed. So 4 times 3 cubed is 108. Multiplied by 2 is 216, so we have 216x. And then the last one there, we've got 6 times 3 squared. So 6 times 3 squared is 54. So we're going to have 54 lots of, and then 2x squared, I'm just going to write this down over here, is 4x squared. There we go. So we have 54 lots of 4x squared. So 54 times 4 is 216. So we have 216x squared. There we go. And there is that one, 216x squared at the end. On to our next one here. Let's have a look. We've got a negative getting involved here, so we've just got to be careful because we've got 3 as our first piece and then negative x as our second piece. So let's just get our pattern obviously for a power of 5. So a power of 5, we need 5C0, which is always 1 to start with. So we get 1, 5C1, which is 5, and then 5C2, which is 10. So 1, 5 and 10. So let's have a look then. We have one lot of that first piece, which is 3 to the power of 5. And then we're going to have 5 lots of 3 to the power of 4. And then negative x. And then for the next one, we're going to have 10 lots of, we have 3 to the power of 3, and then negative x to the power of 2. There we go. And let's simplify all of this. So 3 to the power of 5 on the calculator is 243. So 243. Then 5 lots of, so 5 times 3 to the power of 4. There we go, is 405. But that's going to be multiplied by negative x. So we've got 405 multiplied by the negative x, which is going to be minus 405x. So let's get rid of that plus. So minus 405x. and we're going to add to that 10 times 3 cubed. 10 times 3 cubed is 270. Negative x squared is going to be positive x squared. So we have plus 270 x squared. There we go. And on to our last one. And again, let's have a look at what pieces we have. So for our first piece there, we have 2. And the second piece in the bracket, we've got positive 5x, and this time it's to the power of 7. So 7c0 is 1. 7c1 gives us 7. So we have 1 and 7. And then for the last one, 7c2 is 21. There we go. Okay, so for our pieces here then, we have one lot of 2 to the power of 7. And in the next piece, we've got 7 lots of 2 to the power of 6. Should we write that bracket there? 2 to the power of 6. And then 5x to the power of 1. And for our last piece, we get 21 lots of 2 to the power of 5. And then 5x squared. There we go. So simplifying this down, 2 to the power of 7 is 128. So we get 128 plus 7 lots of 2 to the power of 6. Well, 2 to the power of 6, just on the calculator, is 64. Timesing that by 7 is 448. And timesing that by the 5 in front of the x there gives us 2,240 x for our first one. And then for our last piece here, 2 to the power of 5 there in the bracket is 32. Multiply that by the 21 is 672. And then obviously we've got 5x to the power of... what's that last one there? 5x to the squared there. So 5x squared is 25x squared. So we've got 672. We'll times that by the 25 now, and we get 16,800. There we go, 16,800 x squared. There we go. So obviously some quite big numbers in this one, so don't let the big numbers put you off. Sometimes you are going to get very large numbers, but obviously you've got your calculator, so all you've got to do is type in 21 times 2 to the power of 5 times the 25 there. Obviously just making sure you are careful with the brackets in those scenarios there. Obviously there was a couple of times that came up here. We had the 2x that was being squared that made the 4x squared, and the 5x here that was being squared that made the 25x squared. Obviously just being careful with what coefficient of x that you are actually multiplying by there. But there we go, that is obviously some of the binomial expansion there, where we've just got not necessarily nasty pieces in the brackets, but we're going to have a look at some now where we have fractions in the brackets and how we go about dealing with those as well. So let's have a look at that. Okay, so this question says, find the first 4 terms in ascending power of x of the binomial expansion of 3 minus a third x to the power of 5, giving each term its simplest form. So let's have a look at this one. Now we've got a power of 5, so before we start dealing with the fractions and having a look at how we're going to deal with that, we'll find the first 4 terms in the pattern here. So we'll go for 5c0, 5c1, 5c2 and 5c3, and just work out what that pattern actually is. Now obviously we know the first one's 1, so we go for 5c1, which is 5. The next one, 5c2, is 10. And the next one, 5c3, is also 10. There we go. So that's how many lots of this pattern we're going to have. Now this time the first piece in our pattern is a 3, that's okay. And the second piece in our pattern is negative a third x. Now obviously that's okay as well, but we're just going to have to be careful when we're typing this into the calculator. Another way that you could write this here is you could write negative x over 3. So you could leave it as that as well. I might actually write it as negative x over 3 instead, just to sort of make the terms a little bit easier to write. But let's go for this then. So we have one lot of the first piece, which is 3 to the power of 5. So we've only got 3 more to do now. And we're going to add to that. We've got 5 lots of for the next piece. Let's just highlight these as we go. So now we're on this 5 lots. So we've got 5 lots of, and we have 3 to the power of 4. And then we've got this negative x over 3 as well. So negative x over 3. There we go. On to the next piece. Again, so we have 10 lots of this one. So we've got 10 lots of. So we've got 10 lots of, and we've got 3 getting down to the power of 3. And then we've got this negative x over 3, which is now being squared. There we go. And then for our last piece here, again, we've got 10 lots of this. So we have 10 lots of 3 going down to a power of 2. And we've got the negative x over 3, which is now going to be cubed. Right, so let's deal with all these pieces. The first one's okay. We've got 3 to the power of 5. We can work that out nice and easy. That's 243. So we have 243 as our first one. You can always tick these off as you go, so that's done. The next one, 5 times 3 to the power of 4. Well, let's work that out to start with. That's 405. So 405, and that's going to be multiplied by negative x over 3. We'll come back to that and deal with that in a sec. On to the next one. So we have 10 lots of, so 10 lots of 3 cubed. So we have 3 cubed, which is obviously 27. Times that by 10 is 270. So we have plus 270 lots of, and let's have a look. Negative x over 3. Well, if we square that, it's going to become positive. So we're going to get x squared on the top, and on the bottom, 3 squared is 9. So x squared over 9. There we go. And that's that pieced out with. And on to the next one, obviously just being careful with those when you're squaring that, remembering that that's going to make it positive. So we get the x squared on the top, positive x squared, 9 on the bottom. On to the next one, 10 times 3 squared is 90. So we've got 90. And that's going to be, and we've got negative x over 3 cubed. So when we cubed, it's going to stay negative. So we're going to have negative x cubed on the top and 3 cubed, which is 27 on the bottom. There we go, and that's the last piece dealt with. Right, now simplifying all of this then. So we've got 243 at the start, that's all good. And then we've just got to be careful on this next bit. Now negative x over 3, just obviously we could have had the negative a third there. We basically just want to do a third of 405. So if we do a third of 405, we have 405 divided by 3 is 135. And obviously it's negative there, so it's going to be negative 135x. There we go. On to the next piece, we have 9 on the bottom there, so we want to divide that 270 by 9. Obviously it's positive this time, so we'll divide that by 9. 270 divided by 9 is 30, so we get 30x squared. On to the next piece, 90 divided by 27 is not as nice, it gives us a fraction here, and got to be careful because it's negative, so that's not going to be plus there, it's going to be minus. So we get minus 10 over 3, which is what 90 divided by 27 comes out as, with an x cubed. There we go. And that is those first four terms finished. So obviously just be careful on this, because obviously sometimes you can get these fractional pieces or these fractional coefficients here, and that is quite common on these questions, so you just need to be nice and careful. And obviously just watching out for any pieces here that are negative, like the 2 there, just making sure that you show those with your negatives here as well. When you do have these fractions involved, just remember obviously you're just finding a fraction of that coefficient there. Again, it's just like 405 multiplied by negative a third in terms of actually getting these coefficients. So here we've got the 135, a third of that, and 1/9 of 270 gives us the 30. Obviously our fractional piece at the end as well there. So just being careful, there's the first 4 terms in ascending powers of x, and we've simplified each term. So obviously don't be put off by these fractions within the brackets. We're going to have a look at one more of these before you have a go. So this one here is very similar. It says find the first 4 terms in ascending powers of x of the binomial expansion of 1 plus x over 4 to the power of 12, and again giving it in its simplest form. So we've got a power of 12 this time, which doesn't look very nice, but if we start putting them in, 12c0 is obviously 1, so just power of 12, so our first one in that list there is 1. We have 12c1, which is 12, we get 12c2, again let's just type this into a calculator, 12c2 is 66, so that's looking quite nasty now, and 12c3, which is 220. There we go. Definitely doesn't look very nice on this particular question here. So obviously going ahead with this then and finding all these terms, let's see what we get. So we have 1 lot of, and again our pieces are 1, and we have positive x over 4. So we've got 1 lot of the 1 to the power of 12. We're going to add to that. Just moving down our list here. Now we're on the 12 lots. So we have 12 lots of 1 to the power of 11. And we have the x over 4. There we go. And on to the next piece. We have 66 lots of this one. So 66 lots of 1 to the power of 10, and then x over 4 squared. And then for our last piece here, which we have 220 lots of, so we have 220 lots of 1 to the power of 9 now, and x over 4 to the power of 3. Right, there we go, and let's just go about simplifying all of this. So 1 to the power of 12 is 1. This is quite nice because we get these 1s here, so that 12 times 1 to the power of anything, that's just going to stay as 12. So we have 12 lots of x over 4. Then we have 66 lots of, and we've got x over 4 squared. which is x squared over 4 squared, which is 16. And then for the last one, 220 times 1 to the power 9 is 220. So 220 lots of, and we get x cubed over 4 cubed, and 4 cubed is 64, so it's x cubed over 64. And there we go. And then obviously just simplifying this down again, 1 at the start stays as 1. 12 divided by 4 there, obviously we're doing a quarter of this, so that's 3, so 3x. Then we have 66 divided by 16 for this next piece, which is 33 over 8, not very nice. So we get 33 over 8, lots of x squared. And then we've got the last piece there, which is 220 divided by 64, which gives us 55 over 16 as a fraction. So 55 over 16, x cubed. There we go. So as I said again, we're getting these fractional coefficients of x squared and x cubed there. But again, that shouldn't put you off. Obviously, we're just typing it into a calculator. So 66 over 16 just gave us that 33 over 8, and that's 55 over 16. Okay, but there we go. There's our final answer. There is the first 4 terms in ascending powers of x. And obviously just showing you there not to be put off by these fractional pieces. But there we go. We're going to have a couple of questions for you to have a go at, so let's have a look at those now. Okay, so here's your 2 questions. So pause the video there, have a go. We'll go over the answers in a sec. Okay, so for this first one then, our first piece is 2, and our second piece there is negative x over 4. So obviously we've got a power of 10 there, and we're finding the first 4 terms. So we'll do 10c0, which is 1, 10c1, which is 10, 10c2, which is 45, and 10c3, which is 120. There we go, so there's our first 4 terms for the pattern then, or first 4 pieces of the pattern. So we have one lot of the 2 to the power of 10. We're going to add to that. We've got 10 lots of 2 to the power of 9. And then we have the negative x over 4. Then for our next one, we've got 45 lots of this one. So 45 lots of 2 to the power of 8. And then we have the negative x over 4, which is all going to be squared. And then for our last piece, we're going to have 120 lots of, we have 120 lots of, let's have a look, 2 to the power of 7. And then we have our negative x over 4, which is going to be up to the power of 3. Right, there we go, so that's our first 4. We just need to simplify this down. So 2 to the power of 10, I'm just going to do that on the calculator, is 1024. So 1024. Plus 10 lots of 2 to the power of 9, so 10 times 2 to the power of 9. Let's have a look what that comes out as. That comes out as 5,120, so 5,120. And that's obviously being multiplied by negative x over 4. Then we have 45 lots of 2 to the power of 8, so 45 times 2 to the power of 8 is 11,520. There we go. And then we have the negative x over 4, which is being squared. So negative x over 4 squared. So if I think about what that is, that's going to be positive x squared over 16. So we have positive because it's negative being squared. So we have x squared on the top, and 4 times 4 is 16 on the bottom. There we go. 120 times 2 to the power of 7. Let's work that out. 120 times 2 to the power of 7 is 15,360. So plus 15,360. And then we have in the bracket there, negative as it's being cubed, x cubed on the top, 4 cubed on the bottom, 4 cubed is 64, so 64 on the bottom. There we go. And then we just need to tidy all of this up, so let's have a look what we get. We've got the 1024 at the start, so 1024. Then we've got 5,120, we've got x over 4, so we need to divide that by 4. So 5,120 divided by 4 is 1,280, and that's going to be negative with the x there, so negative 1,280 x. Then we're going to add to that, the next piece is going to be positive, so 11,520 divided by 16 is 720, so plus 720, and we've got x squared. There we go. And for the next piece, we've got 15,360. We're dividing that by 64 this time, which is 240, and it's a minus over there, so being careful with that. So we've got minus 240 x cubed. Right, there we go, and that is our first question there completed. Right, now we're going to need a bit of space for the next one, so I'm going to get rid of all this working out. Let's get rid of that. There we go, and we'll move this up. That one's finished. There we go. Okay, so on to our next one. Now for our powers for this one then, let's have a look. Now for our first piece there, we have a 1, and for our second piece there, we've got positive x over 4, and it's a power of 8. So if we do 8c 1, 8c0 and 8c1, let's have a look, that's 1, then 8, 8c2 is 28, and then for our last one there, 8c3 is 56. Okay, so we've got one lot of, I'm going to do this down here, so we have one lot of the 1 to the power of 8, then we have 8 lots of the 1 to the power of 7, and then the x over 4, and then we have 28 lots of 1 to the power of 6, and then the x over 4 squared. And then for our final piece here, which we have 56 lots of, we've got 56 lots of 1 to the power of 5, and the x over 4 to the power of 3. Okay, so let's simplify this down. Let's see what we get. 1 to the power of 8 is 1. And we've got 8 lots of 1, so that's 8 lots of x over 4. Then we have 28 times 1, which is 28. Lots of, and we've got x squared over 16 on the bottom. There we go, squaring x over 4. And then we have 56 times 1, which is 56. So 56 lots of, and then we've got x cubed on the top over 64. There we go. Right, that's quite nice and easy actually to just expand those pieces because of that 1 in there. Always makes it quite nice. So to finish this off then, we've got 1 plus 8 divided by 4 there, which is 2. So 2x. 28 divided by 16, let's do that on the calculator. That gives us 7 over 4. So we get plus 7 over 4 x squared. And for our last one there, we've got 56 divided by 64, which gives us 7 over 8. So plus 7 over 8, and then that's with the x cubed there. There we go, and there's our final answer. Okay, so there we go, we had 1024, take away 1280x plus 720x squared minus 240x cubed for the first one. And then for our final one here, we had 1 plus 2x plus, and then we got some fractional coefficients, 7 over 4x squared, add 7 over 8x cubed. And there we go, there's our final answer. Obviously just being careful with those fractional pieces and just being careful. Obviously all we need to do is type these into the calculator as we go, so it shouldn't really throw you those sort of fractional pieces there, because obviously your calculator will simplify that for you. But there we go, that is obviously some of this binomial expansion with non-fractional pieces in the bracket and with fractional pieces in the bracket. Now we're going to have a look at some of these problems that we had a look at right at the start of the video, and have a look at how to solve those using these processes. Okay, so this question says find the first 3 terms in ascending power of x of the binomial expansion of 1 plus px to the power of 10. It says where p is a non-zero constant and give each term in its simplest form. So obviously p is an actual number that we're going to find. And obviously it hasn't asked us to find that yet, it's just asking us to find those first 3 terms. In the next part of the process though, or the next part of the question, it says given that in the expansion the coefficient of x squared is 9 times the coefficient of x, find the value of p. So we're going to find that value of p later on in the question. And then it says hence write down the coefficient of x squared, and we're just going to follow this step by step and have a look at how to approach this, and then you've got one to have a go at. So finding the first 3 terms then, we've got a power of 10, and just bearing in mind our first piece is a 1, which is always nice, and our second piece is this plus px. So as we've got a power of 10, we need to do 10c0 to start with. So we've got 10c0, which is 1. We're only finding the first 3 terms, so we've got 1, 10c1 is 10, and then we have 10c2, which is 45. There we go. So that's how many lots of each we're going to have on this particular one here. So for this one then, we've got 1 lot of, and then that's 1 to the power of 10, the first piece. And we're going to add to that, we've got 10 lots of, and it's now 1 to the power of 9, and then px as our second piece. And then for the final one, we have 45 lots of, 1 to the power of 8, and then px to the power of 2. There we go. Right, so if we simplify this down then, 1 to the power of 10 gives us 1 for our first piece, 10 times 1 and then times the px gives us 10px. So we have 10px for the second piece. And then for our final piece there, 45 times 1 is 45. And px in brackets squared squares both those letters, so we get p squared x squared. There we go, squaring both of those letters. So 1 plus 10px plus 45p squared x squared. And there's our first three terms in ascending powers of x. Now it says, given that in this expansion the coefficient of x squared is 9 times the coefficient of x. Well, the coefficient of x squared, let's have a look and let's highlight that, is 45p squared. That's what's in front of the x squared. And the coefficient of x is 10p. So what it's saying is, okay, if one is 9 times the other, it's saying if we multiply this coefficient here by 9, it would be equal to this coefficient here. Or in other words, 9 times 10p is going to be equal to 45p squared. Or you could do it the other way around. We could do 10p is equal to 45p squared divided by 9. Completely up to you which one you do. Obviously 45 nicely divides by 9, so that would be quite a nice way to do it. But I'm just going to follow this process as I've written it down this way now. It doesn't really matter which way. It's probably easier actually to divide it by 9, because I think we're going to divide it by 9 anyway in a sec, but let's have a look. So if we times that by 9 anyway, we get 90p equals 45p squared. And then we just need to solve that as an equation. So dividing both sides by p would obviously remove the p from the one side, so we'd get 90 equals 45p, just dividing both sides by p there. Then we could divide both sides by 9, or we could actually divide both sides by 15, completely up to you, or we could just divide both sides by 45, and that'll tell us what p is. So if I divide both sides by 45, just write that down, divide by 45, as we've got 45p there, we get 2 equals p, or p equals 2. And there we go, there's our answer for that part. So p equals 2 or 2 equals p. Then it says, hence write down the coefficient of x squared. Well, the coefficient of x squared is 45p squared. There we go. And we now know that p is 2, so that's 45 multiplied by 2 squared, which is 45 times 4, and 45 times 4 is 180. And there we go, there's our coefficient of x squared, 180. Right, there we go. So there's our final answer. So in terms of actually what we did there, obviously we had a different piece within our bracket. We had a px. I'm just being careful with that. I think the point, the way you need to be careful with it is obviously this bit here where we get the p squared x squared. I think other than that, the rest of it was quite nice and simple. And then obviously just reading the wording carefully, it said one coefficient was 9 times the other. So obviously multiplying that by 9 or dividing the other one by 9 there gave us a little equation to solve. We got our value of p and then sub that in to find the coefficient of x squared. So hopefully nothing too horrible there, but obviously here's a question for you to have a go at, and then we've got one last one to finish on. So let's have a look at that one now. Okay, so here's your question. So have a read of this one, pause the video there, and we'll go over the answer in a sec. Okay, so finding the first three terms then. So we've got a power of 5, so we're going to do 5c0, which is 1, 5c1, which is 5, and for the last one we've got 5c2, which is 10. And we've seen this power of 5 one quite a lot throughout this video, so hopefully you're recognising that pattern by now, 1, 5, 10. And let's have a look then. Our first piece is a 3, and our second piece there is a bx. So let's find these first three terms. So we have one lot of the 3 to the power of 5, and then we have 5 lots of 3 to the power of 4 and the bx, and then for our final piece we've got 10 lots of 3 to the power of 3 now, and then bx to the power of 2. There we go. Okay, so simplifying this down then, 3 to the power of 5 is 243, so we get 243 plus 5 times 3 to the power of 4, which is 405, so plus 405 bx, plus 10 times 3 cubed, well 3 cubed is 27, so times it by 10 is 270, so 270, and then squaring bx gives us b squared x squared. And there we go, and there's our first three terms. So given that in this expansion the coefficient of x squared is twice the coefficient of x, find the value of b. So again, completely up to you whether you double one or halve the other, but our coefficient of x squared is 270b squared, and the coefficient of x is 405b. So it says the coefficient of x squared is twice the coefficient of x. So again, completely up to you whether you double one or halve the other. I'm going to go for halving this one this time. So we have 405b is equal to half of that. So 270 divided by 2 is 135 equals 135 b squared. There we go. Divide both sides by b to start with, or however you like really, but we get 405 equals 135b. And then we can divide both sides by 135. So 405 divided by 135 equals 3. So we get 3 equals b, or b equals 3. There we go, and there's our value of b. Then it says, hence write down the coefficient of x squared. Well, we already know x squared up here. We have 270b squared is our coefficient. So 270b squared. If I substitute 3 into that, we get 270 times by 3 squared. So 270 times 9, which is 2,430. And there we go, there's our coefficient of x squared in this binomial expansion. Right, there we go, so that's the final answer for that part. Hopefully you found that quite nice and simple. Obviously, following some of that process, I've got one more question for you to have a look at before we finish here, so let's have a look at that one now. Okay, so this question isn't really any more difficult than the previous two, just another question for you to have a go at really, with some slightly different wording in the second part there. It says, given that in this expansion the coefficient of x is 48, find the value of k. So pause the video there, have a read through this, have a go as our last question, and we'll go over the answer in a sec. Okay, so the first three terms. Now it's to the power of 5 again, so we've got our first three pieces are 1, 5 and 10. And we just need to obviously work this out. So our first piece in there is a 2, and our second piece there is kx. So we have one lot of 2 to the power of 5, and then we have 5 lots of, we've got 2 to the power of 4, and the kx. And then for our final piece, 10 lots of 2 to the power of 3, and then our kx squared. There we go, and if we simplify that, 2 to the power of 5, let's work that out, 32. 5 times 2 to the power of 4, let's work that out, 5 times 2 to the power of 4 is 80, so we have 80 kx. 10 times 2 cubed, 2 cubed is 8, so that's 80, so we get 80 k squared x squared, and there we go, squaring kx. So there's our first three terms. It says, given that in this expansion the coefficient of x is 48, find the value of k. Well, the coefficient of x is 80k, so it says that 80k is equal to 48. So if we write that as an equation, we get 80k equals 48. So straight away we can just divide both sides by 80. So k is equal to 48 over 80, which if we work out in the calculator, simplifies down to 3 over 5. There we go, which equals 3 over 5. Or you could write that as 0.6. And then it says, hence write down the coefficient of x squared. Well, the coefficient of x squared, let's have a look, is 80k squared. So we just need to sub that into there. So let's have a look, we get 80 k squared, and we know that k is 0.6. So we can do 80 multiplied by 0.6 squared, and let's see what we get. So 80 times 0.6 squared gives us 144 over 5, or if we write that as a decimal, 28.8. There we go. Okay, so we've got our value for k, was k in this, wasn't it yet? K, which is 3/5 or 0.6, and then we sub that in to get our coefficient of x squared, which came out as 144 over 5, or 28.8 if we write it as a decimal. Either one's absolutely fine though. And there we go, that is the end of binomial expansion. Hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe. I'll see you for the next one.